Okay, so we will start whatever we have discussed in class. After that, we will move forward in topic electrostatic. Take care. Electrostatic. So we were discussing regarding the property of the charges at rest, in which we have reached at the topic dipole, electric dipole. So today we had discussed what is electric dipole and what is electric dipole moment. So electric dipole moment. We had simply defined this given term. So mathematically we have to express how can we define. So we had shown when two charges, equal and opposite charges, are separated by the small distance, then it may be regarded as a dipole. Okay. So in which the distance must be very small. So now in the case of the dipole moment, this dipole moment will be represented by P, and simply it is a vector quantity. So we had shown how its direction will change, how its direction will move. So we had shown that between the two dipoles how the distance is represented. बोर्ड क्लियर आ रहा है सबको? चलो ठीक है जी. The electric dipole moment, we have simply defined that the product of either the charge means as plus q and minus q, both are having the equal magnitude. Their mod we have taken this and between this direction. So simply we take this distance as twice of a. Take care. Generally distance we have always taken like r, x, but this time we are taking as twice of a. Then we will say, sir, what will be the value of the dipole moment? After writing the definition, we can represent P is equal to product of either of the charge, mod Q means Q into 2A means 2AQ. Just see why 2AQ. Why the distance have been taken as twice of the A? For the convenience, further when we will have a discussion regarding the mathematical calculation, we will see while having the midpoint, center point between these two charges, that will be simply A. If we will take twice of A, the center point can be taken as A. If you will take this distance as A, then midpoint will be A by 2. But if you take 2A, it will be simply A. That's why in the calculation, for some of the convenience or making it easier, we have taken this distance as twice of the A. This is general concept regarding why the distance is taken as A. Let's see. So P is equal to 2QA. This is A. Or you can write simply P is equal to 2QA. This is the dipole moment or electric dipole moment. So we had simply defined. After the definition, you need to just write the mathematical form. Just write the mathematical form. In classroom, we had simply defined, and after that definition, you can write this formula. And after that, you can draw the diagram. So just see one more thing I will like to say. Here we will take minus here plus. Why? Because we had just written that from minus to plus. So this will show the direction of the dipole moment. So here you have to take minus q, here plus q. This will give the direction. Just draw the diagram and write the mathematical form of the electric dipole moment. After that, where we can have such type of the electric dipole, we had simply given the example in the case of the small bar magnet, which is simply separated by very small distance. Their poles are situated at very closer to each other. That may be regarded as one of the electric dipole moment. So here we will also have some of the discussion. after writing its formula, dimensional formula, SI unit. Just see, if you talk about the SI unit, Q is the charge, it's the coulomb, A is the distance, and distance is simply meter. So you can write COULOMB, coulomb meter. Just see, cm, it is not centimeter, it is coulomb meter. And after that, dimensional formula, just see, dimensional formula. Q, Q is simply I into T. I is the current ampere and T. So simply A T, and this A is the distance. Distance means what? MLT. So it is simply L. So just see L, T and A. So if you arrange it in a particular manner, you can write it simply, just see, M0 L T A. This is the dimensional formula of the electric dipole moment. Just see. Sign, it shows it is a vector quantity. So already we have shown it through the arrow. So this is the initial knowledge regarding the electric dipole moment. If you say, sir, some of the examples, some more examples, then in the case of the water, its molecules like oxygen and hydrogen, between them there is a formation of the electric dipole moment. Say H2O means simply in the case of water, and hydrochloric acid, HCl, etc. These are the examples where electric dipole moment can be seen, can be obtained. Just note down, we will erase and we will move further. Just see. So in the case of the water and hydrochloric acid, there is an electric dipole moment. Okay, it's a visible. I will erase, then I will move forward. Still number of students are very less. Tomorrow I will talk in class regarding your attendance. Okay, tomorrow I will see how many students are present here and where the still are. Others, what they are doing, I am just having the attendance and will also share in the group. Okay, okay, should I erase? Okay. Now some of the topic related to these points. So our topic is now we have to find the electric field. In the case of the charges, we had also found the electric field due to point charge, due to system of point charges. Now here we have to see electric pole will be there, and we have to find the, there is some of the disturbance phone calls. Okay, so just see, we have to find electric field. Topic is to find electric field when when the dipole is present and the line means along its axial line. Axial means simply along the axis. You know, if the dipole is here, plus q minus q, so this is the line along the axis, means this is simply axial line. So we have to find such type of electric field in the case of axial point. So electric field at an, Just this is the heading. You have to note the heading, then we will move forward. So we have to find the electric field at an axial point of a dipole. This is our topic. So we will draw, we will find in the case of dipole where to find electric field at an axial point. Means if you will draw the diagram, just see this is minus q, this is plus q. Just see this is the dipole and this is the center point, means this is the midpoint of these two charges, means it is a, this distance is a, this is a. So simply this is twice of a and this is the direction of electric dipole moment, negative to positive. Just see through the diagram. First of all we have to see, so along its axis, this is axial point, means any point that will lie along the axis. So this may be moved forward and along this, suppose there is a point, this is a point P. Just take care. This P represent electric dipole moment. This is the point P which is on an axial point. This is simply axial point. Point P is axial point. Why? This point is lying on the axis along the line that joins these two charges. So this P is axial point. We will write, we will mention. So you have to find electric field at this point. So what will be the effect of electric field due to this charge plus Q, and again you have to find the electric field due to this charge minus Q, and after that what will be the total electric field at that particular point, which is an axial point of this dipole. Clear? So this point P, where it is situated? So this point P is at a distance r from the midpoint. Midpoint, in the case of circle, we always find the distance from the center. So just like that, here that point location is at r from the, you can just write this center as O. From O, this point is at distance r. Now, two electric fields will be set up. So this is also electric field and this is also electric field. Now see, E is the electric field. First, due to plus Q, second due to minus Q. So what will be the direction? One is in this way, another is in this way. So just today in the class, we had shown the pattern of the electric field lines due to single positive charge, outwards, inwards, two things. So this is E. Now due to plus Q, what will be the direction? So here you can write this is E plus Q, this is E minus Q. Just see, electric field, this shows the direction, in which direction it is acting, outward, inward. So this is due to two charges, minus Q and plus Q. So this is the diagram which we have to proceed further. Just note down the diagram, we will proceed further. First of all, we will clear the meaning that what does this P represent. Just you can write, let this P, only P, not this P. This P is electric dipole moment. So this P is what? Point. Where this point is situated? On axial line. Just see, on axial line, this along the axis. And what is its location? At distance r. So point on axial line at distance r. Just see, this distance is r from center O of this electric dipole. So point on axial line at distance r from center O of the dipole. Just see, we are talking about this. So this is about this particular point, which includes about this value r. Now one by one Your target is to find the electric field at point P due to charge plus Q, due to charge minus Q, and then the total charge experienced or created at point P. So now you can write electric field where at point P due to charge Q. Electric field at point P due to charge. One by one, you have to write the value of charges due to charge minus Q. माइनस क्यू चार्ज के कारण इस पॉइंट पी पर कितना इलेक्ट्रिक फील्ड होगा जी, उसका मैग्नीट्यूड को हम लोग यहाँ पर रिप्रेजेंट करेंगे. इसको लिख रहे हैं ई माइनस क्यू बराबर ये. So what will be the value of this E minus Q? Today we have just written. Just remember 1 by 4 pi epsilon naught. Just don't write. Just try to understand. Then we will put this value. 1 by 4 pi epsilon naught Q by R square. So this R can be taken in different form. R1P, R2P, R1, whatever. So here the charge is minus Q. So what will be the value? Minus Q by 4 pi epsilon naught. Just see, Q by 4 pi epsilon. Instead of Q, we have minus Q. So this, and what is the distance? Minus Q, just see, distance of minus Q. This is R and this distance is A. So the distance becomes what? 1 by R plus A square. 1 by R plus A square, and this is any unit vector P. That P is not this P, not this P. It is simply the unit vector P. Once again, instead of this distance R, we have written R plus A. This is R. And this is total 2A. So this is A, this is A. So this is R, this is A. Total distance of minus Q charge is R plus A. So you can write here only regarding this P. You can write where P is unit vector. So there will be no any confusion. Similarly, you can write similarly E plus Q. Simply Q 4 pi epsilon naught 1 by R plus A square P unit vector. Just see, only there is a difference of the nature of charge. This is minus Q. You can write here, this is plus Q. Only this is the difference in the sign, but no other things are different. Just see. Okay, this is now full board is coming. You can see. Once again, instead of this negative charge, we have just put the value of the positive charge, same value. Now, what will be the value of this A? Just see, this is R and this Q is less A. So, this A will become R minus A. If anyone having any type of the doubt regarding these two terms, you can ask. I think it's a very simple method through which I am moving forward. So, there will be no any problem to anyone. Okay. So just note down so that I can move forward. P is only the unit vector. Okay. So should I move forward? Have you noted down, you all? Yes, you can write through the chat box. In chat box, you can write. Okay, thank you. So now we have find these two values, E plus Q, E minus Q. So the total, that is the resultant or effective electric field at point P, we have to find. Now you can write total Now total electric field. Total means resultant, effective, whatever. Total you can write also like the resultant. So total electric field at point P is E is equal to E minus Q plus E plus Q. Just see the total electric field can be represented as E, which can be simply the sum of these two fields. So what we had often just only there was a difference in the sign. So you can write Q divided by 4 pi epsilon naught. Just see 1 by R plus A square minus 1 by R minus A square, and this is the unit vector. Just see, is it right or wrong? Is it right or wrong? So this will be simply the value of E plus Q. First of all, U plus Q, E minus Q. Why? Negative sign having the positive value, positive sign having the negative value. This. So it will simply create the problem. So here it was simply minus. Positive value, positive this less A. So it is R minus A. And this is plus A. So this will be R plus A. Take care. Note down. First of all, come to this point. We will simply have a mathematical calculation. Very simple calculation we will do. P is the common, that is the unit vector. So this is common now. You can move forward or directly you can write 4 pi epsilon naught. Just see the multiple. What will be happen? R plus A square minus R minus A square. A plus B square. A minus B square. What will happen there? A square B square 2AB minus A square B square minus 2AB. So minus minus plus R square A square will be cancelled. Only you will get 4AR. Just see. And product of these two, R minus A into R plus A whole square. A plus B, A minus B. What will be there? A square minus B square to the power 2. This into this square. So this will be the solution you will get. Just check if you are having any confusion. That's how it came. I will elaborate. You can go through in detail if you are having any problem, or I think everyone will be clear. Okay, is it clear now? Should I move forward? So now come. We are just combining together. All the terms I am going to combine together. So what will happen? Just see. 1 by 4 pi epsilon naught. This Q. 2, just take common. 2AQ. 2AQ is dipole moment P. So it will be simply 2PR. Just see. It will be simply 2PR divided by R square minus A square square, and this is simply unit vector. Just see if you are having any problem. That's how it came. You can ask anyone. Anyone having any type of doubt? Actually, what we have done? Just see. Q4AQR. 4AQR can be written as 2 into 2AQ into R. This 2AQ. P is equal to 2A into Q. So this will give 2PR. This P is the electric dipole moment. Okay? It's clear to all of you? So directly I have written this how it came. Now The final result we will have. Now you can write this R and A. R, what is R? R is the distance from the dipole, center of dipole. A is what? The distance between two charges, two dipoles, or you can say this plus and minus, this distance is very small, and instead of that 2a that is very small, the a will be very less. So if we neglect that type, like for r much greater than a, if r is much more greater with respect to a, then what will happen? This a square can be neglected. Then what will happen? This a square will be neglected. Simply r to the power 4, and this r, one r will be cancelled, remaining will remain r cube. So what we can write here? E is equal to the total electric field, that is the resultant. E can be written as 4qa. This 4qa, r has been cancelled, by 4 pi epsilon naught. Just see, 4qa, r has been cancelled, 4 pi epsilon naught, and this will simply represented as r cube, and this is the unit vector, this. Or in other word, in this word, if you cancel this 2 in the form of 2p, you can write like this: 4 pi epsilon naught 2p, 2p by r cube. This is the unit vector. This is the value. R square 4. A has been neglected because A is much less than R. So remaining is only R cube. This R cube. 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. 2p. 2p. 1 R cancel with one of the fourth R. Similarly, this term we have written above. Just note down. This is the total electric field or resultant that can be obtained at the axial point P. So you can write this is the total value of electric field. This in two way. This way, this way. Do fast. Okay, is it clear? So this is the positive value. Positive value that show here this P. This electric field will act along the direction of this electric dipole moment. So you can also write, because in the next term we will see the electric field just opposite to the electric dipole moment. So where you will get negative value. So here we have got the positive value. So you can also write, what you have to write? You can just write E acts. This electric field means the total field that is at particular point P acts in the direction of this P. He acts in the direction of, after writing this you can write in the direction of this P. He acts in the direction of P. So in very next term we will see how this E acts just opposite to the direction of dipole moment P. This P with arrow means simply we are talking about this P, not this P, not that particular point P. So you can also write E acts in the direction of the electric dipole moment P. Move fast. One more topic we have to discuss. Now, electric field, this time we have found at an axial point. Now, one more word is the equatorial plane. equatorial, in the case of equatorial point or equatorial plane. So here we will change the what we have to find this time. This time we have to find the electric field at an equatorial. Just see, equatorial point. We will see how this equatorial point is different from the axial point. So this is electric field at an equatorial point of a dipole. This is our next topic. Only this point has been changed. Sometimes it is written in the case of in case of equatorial plane. Equatorial plane. Both are same. So this time, let us see the diagram. How can we move forward with the calculation? So just try to understand the diagram. If you understand the diagram, calculation is very, very simple. So first of all, we will have the discussion regarding the diagram and then we will move forward. If it will be not completed today, by tomorrow in the class, we will have its discussion. So once again, just see. First of all, we have to create the dipole. This is minus q, this is plus q. So this time point is not lying along the axis. Equatorial means simply this is the midpoint, that is simply O, origin. Just we have written. This time we will give the name point A, point B, where charges minus q and plus q are situated. O is the midpoint. So along this line, just see, along this, you can write in plane, we have to show the if at this particular point. Just see, we have gone through the equatorial, triangle, equilateral, many more we have learned. So at this point, this is the point P this time. So where this point P is lying, this time we have to find this point is simply equatorial point of this dipole AP. AB is the dipole and point P is along the equatorial point, or you can say it is equatorial plane. So what will be the diagram? First of all, just see, here one angle theta is, here again it is also theta. This will be the same. This is the midpoint. So this distance, both distance is twice of A. So simply this will be A, this will be A. Just see, this is the dipole. Now along the axis, along this, just see. Now this is plus Q outwards. This is minus Q inwards. So this will be the direction. Here this will be the direction. Just see. Why it is outward, why it is inward. This is the property. Already we had discussed in our classes. Now these resultants will be simply this. In class 11 we have learned how the resolution, how the addition of two vectors. So this simply these two vectors make perpendicular. Here the line it is not straight, but simply this and this makes 90 degree. Take care. Two lines, they are making angle of 90 degree. So this time this is also theta, this is also theta. So this is electric field E plus Q, this is E minus Q, this is the total electric field E. Just see, already vector quantity you can represent like this. This is the resultant that will represent, this is due to minus q, this is plus q. When these two components will be added, then their resultant will be represented as E. Means E is the total electric field at the equatorial point of the dipole, that is at point P. So just note down the figure. This distance is R. Point P is at distance R. In first case we had written, this time also. Now this is A, this is R. So what will be the value of this? R square plus A square power half under root. This is hypotenuse, r square, a square, under root is 1 by 2. So this value will be r square plus a square. Similarly, this will be also r square plus a square to the power half. Just note down. And here you can also show the direction of electric dipole moment P. Electric dipole moment that works from negative to positive. Already we had discussed.